Okay, welcome back to Mr. Hassan's Maths channel. I'm going to answer now question number 6 from an international GCSE Cambridge paper 4. It's from October 2009. It's quite an old paper. It's an extended syllabus. This was just before they started to do the variant, so there's only one variant of this paper. And this is a question about graphs of functions. So you have these graphs drawn. I'm going to just zoom out so we can see the whole thing, or more of the thing on the page here. So you have these two graphs drawn. Y equals f of x, which is this strange looking curve here, and y equals g of x, which is this straight line that goes from the point A to B. And the graphs of y equals f of x and y equals g of x are shown above. We've got to find the value of f minus 2 and g0. So basically, the way I like to deal with a question like this, it says with f minus 2. The minus 2 here, if you can see, it's basically taken the place of the x. Okay, the minus 2 has taken the place of the x in y equals f of x. So basically, this is what we were going to do. We got to draw the line x equals minus 2. Normally, if it was like a graph, if it was a functions question, an algebraic functions question, we would replace the x in the function with minus 2, if you want to find f minus 2. So here what we do is we draw the line x equals minus 2, and then we see where it hits the curve, y equals f of x, and then we give the y value for that. Okay, that's how we'll deal with this. So we look for the line x equals minus 2. So I'm going to be zooming in and out in these questions so that I can see the whole picture. So x equals minus 2 is a line which the x value is always minus 2. So it's going to be a horizontal line that passes through x equals minus 2. Sorry, it's going to be a vertical line, what I'm talking about. Vertical, not horizontal. A vertical line that passes through x equals minus 2. X equals minus 2. The x value will always be minus 2 along this line. So I've drawn that line now on the grid. Okay, this is the line x equals minus 2. So I'll label that here. X equals minus 2. And I want to see where it hits the line y equals, or the function y equals f of x, which is the curved function, this one over here. So we can see it hits it exactly at this point down here. So what we want to do is we want to show our working very clearly. Okay, so I'm going to go to this point here. It's right here, and I'm going to show a line. I'll make it quite a thin line, and I'll make it dotted. Okay, dashed, and it's going to go from this point here to the y-axis. So we can then read what that point is. That is the value of f minus 2. Okay, so you've got minus 10, and that's minus 20. It looks like each of these is 0.1. 0.1, 2, 3, 4, 5, 6. So it looks like this is minus 10. No, it's not 6 point. This is each of these is 1 unit, not minus 1, not 0.1. Sorry, this is 10, 11, minus 11, minus 12, minus 13, minus 14, minus 15, minus 16. So that's minus 16 here. Okay, this like each of these are 1 unit, because you've got from minus 10 to minus 20 and 10 gaps. So this is minus 16. So we can say f minus 2 is equal to minus 16. And the steps are shown here in the diagram. I've drawn the line x equals minus 2, and then I've found where it hits the curve y equals f of x, and I wrote down the y value of that point. Okay, then I've got to do g0. Well, that's where you put 0. You draw the line y equals 0. Sorry, x equals 0. So this is x equals 0. Replace the x with 0 in the function, which is like drawing the line x equals 0 and seeing where it hits the curve y equals gx. So you can see this is the line x equals 0, which is the y-axis. So I'm just going to label this x equals 0 to show that what I'm doing. So this is the line x equals 0, and we can see that, we can just maybe show it like this, that we're hitting the x-axis exactly here, which looks like that's 18, 19, that's 18.5. Looks like it's 18.5, halfway between 18 and 19. So the value for G0 is 18.5. Okay, so that's the answer to part A. Okay, now we're going to go into part B. It says use the graphs to solve the equation fx equals 20. So what I'm going to do is I'm going to take this equation, okay, fx equals 20, and I'm going to put it on this side here. Okay, so this is fx equals 20. Let me just put it on the side here so we can see what we're doing. So we're going to solve the equation fx equals 20. Now, if you had to solve this equation fx equals 20 algebraically, if we had the equation of the curve, for example, we would replace the y, because remember the function is y equals f of x. It's like you're replacing the y with 20 this time, not the x. You're replacing the y with 20, and then you're solving the equation. So what we're going to do here is we're going to draw the line y equals 20 instead of x equals 20. If it was f20, I'd draw x equals 20. If it's fx equals 20, I'll draw the line y equals 20. So I'm going to draw the line y equals 20, and I'm going to see where it hits the x-axis, the y-axis, it hits the curve. So y equals 20 is going to be this line over here. I'm going to see where it hits the curve. Now it hits the curve at these 2 points. As you can see, one's right over here. I'm going to see the x value of where it hits the curve. There's 1 point there, and there's another point there. As you can see, there's 2 places where it hits the curve. So I'm going to write down those 2 values. This is 4. It looks like each of these is 0.1. On this axis it is 0.1. So minus 4.1 minus 4.2, that's like minus 4.25. The other one is over here, so that's 1, that's 1.2, 1.4. It's like 1.55, I'd say. I've drawn this a bit too much on this side. This is more like 1.55. Okay, 1.55. Okay, so that's 1.5. That's 2, 4, 5. Yeah, 1.55. So here we have the 2 values, 1.55 and minus 4.25. Okay, and now it says use the graphs to solve the equation f of x equals g of x. Okay, so let me just take this equation there. Okay, so let's look at f of x equals g of x. Now, f of x equals g of x is basically where the 2 graphs intersect. That's where they're equal to each other, where they intersect. So let me just zoom out a bit. So we can see that f of x equals g of x is going to be where the 2 graphs intersect. So this is g of x and this is f of x. Y equals g of x is like this. Y equals f of x equals is like this. So the points at which they intersect, we've got to find the x values of where they intersect. So I'm going to take this point here. I'm going to zoom in a bit more so I can see it more accurately. Okay, so I need to find out what the coordinates of this point are. So that will take us down here. And this point here is over here where they intersect again. So these are the 2 points at which they intersect. So let me write down the values for those. Okay, this is minus 4, 1, 2, 3, 4. Okay, minus, it's just slightly out. Let me just make sure where does this meet? Oops, can't do that, can I? Let me do something before I mess up the whole thing. Let's lock this page. Okay, that's better. Now, so this line here, it meets it just, yeah, it's just after that line. So I guess I'm right. I guess if I put minus, that's 4.1234 minus 4.45, I think that would be acceptable. I could put minus 4.4, I could put minus 4.43 because it's slightly to this side. That would also be acceptable. Okay, and the point on this side is going to be 1.123, 1.35. 1.35. Okay, so minus 4.43 minus 4.43. I'm sure if I put 5 it's fine, and 1.35. Okay, that's the answer to part B part 2. And now we've got to solve the inequality f of x is less than g of x. Okay, so we've got to solve the inequality f of x is less than g of x. Okay, so how do we solve an inequality using a graph, graphically? Well, we do it visually. Okay, it's quite simple, because where is f of x less than g of x? Well, let's have a look at the whole thing. Okay, so f of x is the curve. Okay, where it's less than g of x is where it's below it. So if I was to draw a line like this, okay, and if I was to put this at any point here, for example, at this point here, you can see that the value of f of x is greater than the value of g of x. For this x value of 2, f of x gives you a value which is bigger than g of x. Okay, and as you move the line along, that's still true, that's still true, that's still true. At the point that we found, which is 1.35, that's when f of x is equal to g of x. Okay, now where does f of x go less than g of x? Well, to the left of this value. F of x now drops below it. If I find, for example, when x equals 1, if I look at x equals 1, okay, then I can see the value of f of x is less than the value of g of x for x equals 1. And that's the same for all the values after this point. It's below it. The f of x is below g of x for all these values, as you can see. Okay, make the line a bit longer to show it here. Okay, so for all these values, f of x is less than g of x. And it continues to be less than g of x until we get to the other point that we found, okay, which is minus 4.45 or 4.43, whatever we called it. And then after that point, or less than that point, then you can see that f of x is above g of x now. Okay, so this inequality is true between these two values that we found earlier. It's true between when x is more than minus 4.5 and less than 1.35. So the two values that we found, okay, the inequality is true between those two values. So when x is between minus 4.45 and 1.35, that's where this inequality is true, where f of x is below g of x. Okay, f of x is below g of x. Okay, that's the answer to part B. Then it says use the points A and B to find the gradient of y equals gx as an exact fraction. Okay, so let's just go back. A and B. So we got to find the coordinates of the points A and B. Now A is this point over here. Okay, if you look at the point A, it's minus 5, 40. Minus 5, 40. And B is the point over here, which you can see is 2 and 10. Okay, so we have these 2 points, minus 540 and 210. Okay, so we have A is minus 540 and B is 210. Okay, so we want to find the gradient of y equals gx as an exact fraction. So the gradient is the change in y, which you can say is 40 minus 10, over the change in x, which is minus 5 minus 2. So you have 40 minus 10 is 30, minus 5 minus 2 is minus 7. So we can say minus 30 over 7. We can leave it like that. Okay, that's fine. We can also write it as an improper fraction if you want. You can write minus 4 and 2/7 if you want, because 7 goes into 34 times remainder 2. Okay, either of them is okay. Then it says on the grid, draw the graph of y equals g of x minus 10. Okay, so basically we need to draw the line y equals g of x minus 10. So it's going to have the same gradient as this graph, but it's going to be 10 units below this graph. So for example, this point is going to be minus 5. That will go to minus 5. If you take away 10, you're taking away 10 from the y-axis. Okay, if you think about it, from the y values. All right, so y equals g of x minus 10. It's like you're taking away 10 from all the y values. The whole curve drops by 10 spaces. Okay, so what you can do is you can take away 10 from this value. So that becomes minus 5 and 30. And this point, 2, 10 becomes 2 and 0, because you're taking away 10 from the y coordinates. Okay, so y equals g of x minus 10 will go through the points minus 5, 30, which is over here, and it will go through the point 2, 0, which is over here. Everything's dropped by 10 units. So it's going to be a line that goes like this. Okay, of course you can see it's parallel to our line. Of course it should be parallel. Let me just make this line a bit thinner. That's better. Okay, so this is the graph, this is the line y equals g of x minus 10. Let me just label it. Let me make it a bit longer here, and then I can label it properly. So here we have y equals g of x minus 10. We've taken the function y equals g of x, and we've taken away 10 from the y values. That's what it is. So of course it's going to be parallel to the original line, but 10 units below it. It's going to go down by 10 units. Okay, so there we've drawn the line y equals g of x minus 10. Then it says draw the tangent to the graph of y equals f of x at minus 3 minus 27, and then write down the equation of this tangent. So we go to the graph y equals f of x at minus 3 minus 27. Minus 3 minus 27. Okay, so minus 3 minus 27, obviously it's right here. Okay, minus 3 minus 27. See, this is 21, 2, 3, 4, 5, 6, 7, 8. It's exactly here. Right, so just basically it's going to be a horizontal line, isn't it, this tangent? Okay, it's going to be a horizontal line like this. That's where the curve turns. Okay, so this is the line y equals 27, minus 27. Okay, so it said, the question said, draw the tangent to the curve. Okay, done that. The equation of the tangent is y equals minus 27. Right, that was quite simple. And then it says a region R contains the points whose coordinates satisfy these inequalities. And let me take these inequalities. We've got to draw suitable lines and label this region. Okay, so let me just take this and put this on put it somewhere over here. I'll just go out a bit so I can see what's going on. Okay, so let me paste up here somewhere. Okay, make them a bit smaller. Okay, so we have these inequalities. Minus x is between minus 3 and minus 2. Y is less than or equal to 40, and y is greater than or equal to g of x. G of x is a straight line here. Okay, so we've got to draw the line x equals minus 3 and x equals minus 2. And they have to be solid lines because it says equals. So I'm going to draw the lines x equals minus 3 and x equals minus 2. So x equals minus 3 will be a line that goes straight down like this, a solid line. Okay, I need to make it take up the whole space. Alright, let me just move this here so I can see a bit better. Okay, and then I've got x equals minus 2, which will be a line that goes like this. So x equals minus 2. And y equals 40. Y equals 40 is this line that goes across like that. Y equals 40. So this is y equals 40. and this is, I'll just label them down here, x equals minus 3, sorry, and x equals minus 2. All right, now it says, okay, and y is greater than or equal to g of x. G of x is this line here, the a1 going between a and b. So we got to shade. Does it say shade the region? Let's have a look at the question again. Sorry, it says and label this. Okay, label the region R. Okay, all right. So the region R is such that it is between the lines x equals minus 2 and x equals minus 3. So it's between these two lines, and it's less than y equals 40. So it's below this line. So it's between these two lines and below this line. Okay. And y is greater than or equal to g of x, and it's above the line y equals g of x. So it's above this line, between these two lines, and below this line. So it's this region over here. If I was to shade it, I would shade this region right over here. So it's this kind of trapezium shape here, which is between minus 3 and minus 2 on the x, less than 40 on the y, and greater than the graph of y equals g of x. So there we have the region R shaded, and that is the answer to, I think, the whole of the question. Part F, yep, that's done. On the other side, what's there? That's a new question. Okay, so that's question number 6 from October-November 2009, paper 4 in IGCSE Cambridge. Okay, so other questions from this paper you'll find in the playlist that should appear somewhere on the right here, and underneath it you will have a playlist taking you to graphs of functions from IGCSE. You can subscribe to my channel by clicking on this link. On the top of the paper I will take you to a link to maybe one of the newer syllabus papers for IGCSE. Thank you for watching, and hope to see you soon.